Hi, my name is Richard Swan, and for my project I researched the process of desalination. Through my research I learned about the different types of desalination and how this technology could be helpful in easing water needs. This process is concerned with taking in contaminated waters unfit for human consumption, such as salt water found in the oceans, and removing these contaminants in order to produce safe, drinkable water. I believe desalination will be important in solving the water issues of the future. Water issues are becoming increasingly more serious due to population growth and climate change. Climate change specifically is causing more extreme weather patterns, including heavier rainfall in some places and longer, more severe droughts in others. These problems are only getting worse. And with weather becoming more unpredictable, having a reliable source of water largely unaffected by weather patterns would provide security for the future, while other solutions such as conservation, harnessing runoff, and tapping into groundwater sources are definitely useful. I believe another renewable source of water may be needed to secure our water future. Only about 3% of the water on Earth's surface is fresh water, so finding a way to utilize the other 97% would be helpful. This is where desalination comes into play. From my research, I discovered and focused on three main types of desalination: thermal distillation, reverse osmosis, and solar distillation. Thermal distillation uses heat, typically from power plants or other high-energy sources, to vaporize water, separating it from the salt, and then the water cools and condenses into pure, usable water. Reverse osmosis uses a high-pressure pump to force water through microscopic filters to physically separate the salt and other impurities from the water, resulting in a stream of pure water on one side of the filter and a highly concentrated saline solution on the other. Solar distillation is similar to thermal distillation, but uses heat from the sun to vaporize the water, instead of more traditional means. These processes all have their benefits and downsides, which I will get into over the next few slides. The first process I'll be focusing on is thermal distillation. There are three main steps in the process of thermal distillation. The first step is filtering out large impurities, such as sand or rocks. Next, heat is applied to the water to create a vapor. This vapor is then collected and cooled. The salt and other impurities are left behind when the water boils away, and these are discarded as waste. This process requires a large amount of heat in order to complete, and on its own this process requires too much energy to be efficient. However, when coupled with steam power plants, this process can be very efficient. The steam power plant produces a large quantity of heat in the process of boiling water to create the steam which powers the turbines, which generate electricity. After the electricity is created, the extra heat is essentially wasted, as the water cools in order to complete the cycle. Instead of just letting this heat go to waste, it can be captured and used to power thermal distillation, and can fulfill most of the energy requirement. However, most of these steam power plants burn fossil fuels to produce heat, so this process is not sustainable for the future. Without the advantage of being coupled with a power plant, there are more efficient processes than thermal distillation. One of these more efficient processes is reverse osmosis. There are four basic steps to reverse osmosis, and they are pre-treatment, pumping, membrane separation, and post-treatment stabilization. Pre-treatment involves filtering out large particles that could negatively affect the finer filters, along with adjusting the pH and adding a threshold inhibitor. Next, the water is pumped to a high pressure which enables it to be forced through a semi-permeable membrane, which separates the salt from the water. After this has been done, the water goes through another pH adjustment and a degasification process. Reverse osmosis is more energy efficient than thermal distillation, which makes it a better option for the future. However, it does have its downsides. For example, reverse osmosis is significantly more expensive than freshwater treatment options, and the infrastructure is very expensive to build. Another downside is that many reverse osmosis plants are powered by electricity from fossil fuels. This source of energy is not sustainable. A possible desalination technique that could be sustainable long term is solar distillation, which is similar to thermal distillation but uses renewable energy from the sun to heat the water instead of fossil fuels. This process shows a lot of potential for long-term sustainability. Very similar to thermal distillation, the objective is to heat up water in order to turn it into a vapor. This vaporized water is then collected and condensed to form fresh water to be used for a wide variety of purposes. Solar distillation uses parabolic mirrors to focus sunlight on a tube of water running in front of the mirror and to vaporize the water inside. I focused most of my research into solar distillation on a company operating in California called WaterFX. The company claims that their process can desalinate 10 gallons of water per square foot per day, and that this basic formula is scalable to any size desalination plant. The equipment also is capable of storing energy during the day, allowing operation around the clock. Their product was specifically designed to treat runoff water from agricultural land. This water contains lots of fertilizers and tends to be quite salty by the time it reaches the desalination plants. The goal is to recycle this water through solar distillation and return it to the farmers to ease the need for water from California's water-starved rivers and lakes. I believe that in addition to the current use case of recycling water, this technology could also be used in coastal regions to perform ocean water desalination. And of the desalination technologies I have come across, solar distillation is the most suited to providing for the water needs of the future. Unfortunately, desalination does have downsides, and the main one has to do with the saline that is left over as a waste product of the process. It is estimated that for every gallon of pure water created from desalination, 1.5 gallons of saline are produced. In the 20,000 desalination plants around the world, enough saline is produced to cover the entire state of Florida, a foot deep, every year. This saline is usually just dumped into the ocean, but this can have many negative environmental impacts due to both the salt content and the heat of the water. This impact needs to be greatly reduced for desalination to work on a large scale, but desalination definitely has potential to assist in water crises of the future.